Hello, and thank you for joining us. My name is Alan, and I'm here with my coworker Matthew. We are both application engineers with MCAD Technologies, and today we'll be showing you what's new in SolidWorks 2015. Let's get started. In SolidWorks 2015, the user interface has been improved to make your everyday activities simpler and faster. The new View Selection Cube can now be rotated about, and will also show a preview as you hover over the different possible views. Hidden components can be previewed by left-clicking on the part in the feature tree. This will save you from having to unnecessarily show and hide components to get to the right selection. The Isolate feature works in the same way it did in 2014, however now you can isolate based on a common mate. From here we can create a display state for these two cast parts. In SolidWorks 2014, if more components were added to this assembly, they would be visible in our casting display state by default. But now, in 2015, you can right-click and go to Properties and choose to hide new components, and notice I have applied to this display state only selected. This means when new components are added, we will retain this display state, and it will only show the two cast pieces. Moving back to our original display state, we can go ahead and open this front plate in the position it's shown. So I'll go ahead and right-click, choose Open Part in Position, and notice the part file is opened in that same orientation. In SolidWorks 2015, the parent-child relationships have been visualized with this dynamic reference visualization feature. This is able to be toggled off and on in the options menu if you decide you don't want to work with it. But what it does is it will show these blue arrows pointing to the parent and child references for each feature or sketch. Let's go ahead and move to the front view here. If we right-click in the graphics area, we can get to our selection filters. We'll choose to filter by faces. And I'll do a box selection, and we'll select another face here. In previous releases, it would be common to be selecting different faces or edges, and then you would click off of it, and you would lose your selection. From here, you would have to reselect, but in SolidWorks 2015, you can right-click and go to your previous selection to regain the progress that you had made. I'm going to hit F6 to clear our face filter. And now, in 2015, small mouse movements will bring up the face selection, make it a little bit easier to grab those. And you can right-click and save a selection. This will put that selection in your selection sets folder in the feature manager tree. Here's the one we just did, and we have a couple already done. This is useful for your design process so you don't have to keep reselecting the same group of faces, and it would also be beneficial in simulation. The fade-in toolbars are customizable in 2015, so I can go ahead and right-click and choose to customize. We'll go ahead and we can put on a different feature here. Let's put on the extrude. We'll just drop it down, click OK. Now when we right click, we'll see that feature has been added. I'm going to go ahead and select the hole wizard, which was immediately next to it. We're going to go ahead and put in a counterbore hole. In 2015, there have been some changes made to how the toolbox can perform. I'm going to go ahead and right click Configure. This will take a moment to open our toolbox manager. But from here, what I want to point out is we can control when the file name is visible and when the configuration name is visible. So notice the file name is pan_crosshead_am, and I have allow custom configuration names selected. And I have a custom configuration name of Acme M6x8 for the sized fastener that we'll be using. If we move over to the user settings, under display options, you can see we'll see the file name in the feature manager, and we'll see the configuration name in the bill of materials. If we move back to our assembly, we'll go ahead and rebuild it. And now we're ready to put in our fasteners. So I'll just drop in these guys. And if we go back to our feature tree, we'll see our file name is visible here. But if we go Insert, Bill of Materials, we'll put that over here. We can see under the part number, we have our custom configuration name of Acme M6. SolidWorks 2015 has made various improvements to the user interface. Those are the major ones, and it will simplify your day-to-day activities. In SolidWorks 2014, section views were created by choosing a plane, then specifying an offset or a rotated value to create a cross-sectional view. You could use multiple planes to generate the cross-section that you wanted, and you could do that with a variety of inputs, and hopefully you would get what you wanted. But in a lot of cases, customers would need to create assembly level cuts to get the cross-section that they really wanted, because these toggling inputs weren't enough to generate the correct geometry for their documentation. Now in SolidWorks 2015, there is a new section method, zonal section view. This allows you to select the different zones created by these intersecting planes, and you can have multiple zones in a single section view. So I'm going to go ahead and select 3 of these zones. We'll have those all in the same view, and much like previous releases, you can still exclude selected components so you can get the result that you really want. And now in 2015, it is much easier to create complex cross-sectional views for use in drawings and documentation. Exploded views have also been overhauled in this release of the software. You'll notice that you now get to choose between a regular step, a translation, or a radial step, where you explode about a radius. We're going to go ahead and start with a radial exploded step by selecting one of our selection sets. We're going to select this cylindrical face to be exploding about. We'll move those fasteners out, and we'll do another radial step for some more components. We'll select the face, and we can drag them out. You can do radial explodes in the same view that you do linear exploded steps. So now we can box select, and we'll move to a side view. And we have auto space components on drag checked. So now you can move all your components at once, but new for 2015 is there's a slider to help control the amount of spacing that you're getting for all of your components. And of course, you can still individually space components by moving them to the desired location. And that's it for the exploded steps. Some simple tweaks, but they will save a lot of time and have been well received so far. I hope you enjoy them too. SolidWorks 2015 has also made several enhancements to aid in the modeling process. In this example, we'll be using the move face command to make some drastic changes to this grill pan. First, we'll use the move face feature to dynamically extend the end of these grill bars. With the blind end condition selected, we can simply drag the triad out to a specified distance. If we zoom out, we'll see that dimensions coming in. And also notice that you can enter a numerical value right in the graphics window in 2015. In previous releases, this value will have had to have been entered over here in the property manager. We can also select from a variety of familiar end conditions. If we want to do up to surface, let's turn on our view planes. Then we need to select to extend from the specified face and up to the specified surface. This will give our grill bars that angled end. We could also choose to do an offset from surface, where we could, once again, enter in a value directly in the graphics window. Let's go ahead and turn our planes off, and we'll rotate the part and move to the next step. We want to extend this bar up to intersect with this bar. Now, since this is a multi-body part, we can use the move face command. We'll select this face, and we'll choose our end condition to be up to body, where the body that we are extending up to is this outer rail. Lastly, we can use the move face command to make a dynamic change to the entire grill pan. If we go ahead and select move face once again, we'll do a box selection, and we can change the entire design of this plate in a simple movement. So let's go ahead. We'll put in a value of 90. and with one feature in the feature tree, we drastically changed the entire design of this grill pan. SolidWorks 2015 has enhanced the sketching process by adding new workflows and geometry creation protocols to speed up sketch creation. SolidWorks has always had powerful sketch relations and inferencing capabilities. However, in 2015, it is even easier to access these tools. The first thing that I would like to point out is that you can add relations upon the termination of a sketch entity. In this case, I'm going to add another tangent relation to my existing tangent arc. If you have already sketched a sketch entity and want to add relations, you can simply go back and click on it and select the available relation from the Fade In toolbar. When working with splines and arcs, you can add sketch relations by clicking on the shared sketch point between it and the adjacent entity. In this case, I'll add an equal curvature here and the tangent relation up here. Once again, this works for arcs. SolidWorks will determine if a sketched line is closer to horizontal or vertical, and it will highlight whichever one it is closest to in the Fade In toolbar to help you make the correct selection. It is common to want to dimension a full angle. However, when selecting a center line and an angled line, SolidWorks will by default display the half angle. In 2015, holding down the Shift key will allow you to dimension the full angle. After accepting this value, you can go ahead and pick the next angled line, and you will automatically have the same center line selected. Hold down the Shift key to get the full angle. New for 2015 is the midpoint line. The first click will determine where the midpoint of your line is, and then you will extend half of the line down to where your cursor places the second click. SolidWorks will dynamically mirror the other half of the line. Upon termination, you will automatically be sketching a standard SolidWorks line. Of course, adding a midpoint line will add a midpoint relation to your sketch. New in 2015, you can add construction lines to any type of rectangle. When appropriate, you can choose whether those extend from the corners or from the midpoints. In 2015, you can also use the Select Chain functionality for construction geometry. And a nice new feature for 2015 is located under Tools, Sketch Tools. It's the segment. This allows you to break up an existing sketch entity into equal segments or place sketch points evenly spaced along a sketch entity. In this case, we'll break up this line into 6 equal segments. SolidWorks will add necessary relations to maintain geometry as it was initially. If we delete those relations, we can control individual segments and get the result that we want. That looks good. Let's exit the sketch. We could also use the segment tool to equally space out holes for a bolt pattern. In this case, let's add 8 equally spaced sketch points that we could later use for locating hole wizard holes. We can fully define this using the fully defined sketch. If it adds in the dimension that you don't want, you can go ahead and delete that and add the appropriate dimension. Patterns have also been overhauled in SolidWorks 2015. Let's take a look at this linear bearing rail to see the new functionality available within the linear pattern. Currently, we have a linear pattern defined by the number of instances and the spacing of those instances. If we were to change the length of this bearing rail, our part would fail because we would have pattern instances that would not cut the body. In previous releases of the software, we would have to go back and adjust our pattern instances and spacing to get the pattern to generate correctly. However, in SolidWorks 2015, you can choose to set a pattern based on a reference, and it will automatically calculate either the spacing required or the number of instances to put in the pattern. Let's select this vertex as our reference piece of geometry. You can also put in an offset if you desire. In this case, we'll use an equation to match the offset from the other end of the rail. We'll leave our spacing at 60 millimeters, but now we can see as the length of the rail changes, the number of pattern instances will intuitively update. We could also edit this and select the number of instances we would like to have. When this option is selected, the spacing will be recalculated based on the length of the rail. Sometimes it is necessary to work with bodies rather than features. Currently, in this saw blade, we have a carbide tooth that has been merged to the saw blade, resulting in only one cut list item. In order to get a more accurate cut list, we want this carbide tooth to be a separate solid body. However, when we edit the feature and uncheck merge result, our pattern fails. In previous releases of the software, it would have been necessary to delete this pattern and create a new one. However, in SolidWorks 2015, you can edit the pattern and choose between a feature or face pattern or a body pattern. By toggling that option, we can see we get an updated cut list that gives us an accurate count of the required teeth. This is also a nice way for editing patterns that will affect downstream features. The fill pattern has also been enhanced. In SolidWorks 2015, when you edit the feature, you'll have the option to validate the number of instances. This count will be available as a read-only dimension. If the number of instances changes, this value will automatically update. More importantly, this value is available in a drawing. Here, we can add the number of instances to our whole callout. This helps you provide accurate information for manufacturing and fabrication. The last type of pattern I'd like to show is the all-new variable pattern. This ultra-flexible pattern allows users to vary any dimensions that are used in feature creation, but also allows the use of reference geometry, like planes, axes, and 3D sketches that may have been used to create the feature. This reference geometry is important to define the design intent of features on non-planar faces, and all of this flexibility can be controlled in an easy-to-use table or directly on screen. Let's take a look at this colander. All the slots and holes were created using variable patterns. I'll suppress variable pattern 1 and we'll regenerate it to see how the process works. So we're going to pattern using a single feature, this slot. We go Features and select Variable Pattern from the drop-down beneath Linear Pattern. We'll be able to begin our work. We have the slot feature pre-selected, so I can choose to create a pattern table. Let's add one row, and we'll select the different dimensions that we want to vary. We'll choose the angle, the offset, and the length. We know we want 20 slots, so I'll put in 360 degrees divided by 20 to get our optimal spacing. For the slot offset, we know we want 25 millimeters, and we'll also make the length 25 millimeters. Let's update the preview to see what we have. Okay, that looks good. Let's add in 18 more rows and complete our table. Just like Excel, you can highlight two cells and drag them down to continue the pattern. You could also copy these cells, paste them into Excel, edit them, and then paste them back into this SolidWorks pattern table. To maintain the spacing we want, we'll copy these 4 cells and paste them as we move down the rows. Let's update our preview one more time to see what we've got. Okay, that looks good. Let's generate the pattern. Each pattern instance is listed below the variable pattern in the feature tree. To skip an instance, you could suppress it, and if you delete it, it will be removed from the table. The holes were also added to this colander using a variable pattern. Let's edit the feature and take a look at the table that was used to drive them. We can see that we have 4 instances where we control the pitch circle, the number of holes that will be on that pitch circle, and their offset angle. It was only a few clicks and a little bit of information to generate this complex pattern. The variable pattern is a very powerful feature, so let's take a look at some other examples. Here we have a footplate of a soccer cleat. The spikes in the sole of the shoe are defined normal to the non-planar face of the sole, and they vary in position, size, and rotation. They were generated using a variable pattern. Let's take a look and see how it was created. In this case, we're patterning 3 separate features: the spike, the serrations, and the spike base fillet. We're also using a 3D sketch and a plane that is normal to the sole to locate them. If we edit the pattern table, we can see that each spike location is controlled by the X and Y position, the angle of rotation, and the length of the spike. You can also control each pattern instance directly in the graphics window. By selecting it from the feature tree, you can pull up the driving dimensions and edit them to get what you want. Alright, that looks good. Let's look at one last example. Here we have the sole of another shoe. In this part, variable patterns have been used to control the position and definition of splines to provide equally spaced but varying shaped tread patterns as it goes from heel to toe. The variable pattern also controls the depth of the cut to provide the best support and flexibility for the shoe. With the power and flexibility of this new variable pattern feature, SolidWorks 2015 users will have many more options when creating complex geometry. There are some new features and functionality when working with assembly models in 2015. First, let's look at the Profile Center mate. This mate is useful because it allows you to constrain 2 parts based on their geometric centers. So if any of the geometry changes, the mate will resolve to maintain the correct design intent. You can rotate the parts in 90-degree increments to properly orient them. Let's see what happens when we change some of our geometry. Notice how the mate resolved. We can even move this mounting plate down. You can also use the Profile Center mate to constrain fasteners. In this case, we'll use it to constrain these 2 bolts. Notice that when you're working with cylindrical parts, you can lock the rotation. This means you can fully define a fastener with only a single mate. That will surely be big in 2015. The next thing we need to do is limit the range of motion of this arm. Currently, we have a concentric mate, but we want to limit its travel along that axis. Let's use a width mate. New for 2015, there are some different options when it comes to width mates. and the width mate will behave similar to the slot mate. You can now choose between centered, free, dimension, which will specify a certain distance that the part can move, or a percentage of the full range of motion that it can travel. In this case, we'll choose free. This will allow the arm to move between the 4 constraining faces. Looks pretty good. The next thing we want to do is limit the range of motion of this rotating top piece. We can manage this with an advanced angle mate. In 2015, we can also select a reference entity. Notice how this brings up 4 quadrants that we can select from. This allows us to appropriately define the angle that we want to. SolidWorks can also pick up a reference vector for you automatically. We'll select this part of the quadrant. Now all we have to do is put in our values. Okay, it's time to see how this worked. But if you've worked with large assembly models before that have numerous degrees of freedom, you know it can be a bit difficult to test out what you want. New in 2015, there are some options under Move Component. This temporary fix/group feature allows you to momentarily fix certain pieces, so it's easier to test the mate you have just added. Let's resume this drag. We can now see how this top piece rotates just the way we want. You can also fix groups so that they'll move together. And you can even have SolidWorks remember your selections, so the next time you open Move Component, these fields will automatically be populated with what we have here. The next thing we want to do is add another knob to fit in this hole. In 2015, when you go to insert a component, you'll have some new options for how you want to place it. You can rotate it around your 3 axes to help orient it in the best way possible. Now we're ready to mate this. We'll do a concentric mate to line it up. And we'll do a tangent mate to help run it up to this shaft. Okay, that looks good. There are times when you want to make a variation of a part. In previous releases, if we want to make a different version of this clamping knob, we would have had to open the part, make our changes, save it as a new name, and then replace it in the assembly. In 2015, you can simply right-click on a part and choose to make it independent. This will allow you to save it as a new name. This new part will be free of references. Notice the new name in the feature tree as well. When deleting parts in 2015, you can also choose to delete the child features, much like the option you have when working at the part level. Okay, let's do some interference detection to see how our assembly is coming along. When we calculate our interferences, we'll notice there are several interferences due to fasteners. We can go ahead and ignore those. Also note how SolidWorks sorts the interferences from largest to smallest by default, but in 2015, you can choose some other sorting options. Now we have a couple small interferences here because of O-rings, and we're going to choose to ignore these. But rather than ignoring them individually, we can choose to ignore all interferences smaller than the specified one that we are placing this selection on. Okay, so we have 3 interferences left that we need to address. Let's take a look at this part. When we open this part, we'll see someone was already thinking ahead. Let's unsuppress the new bore feature. Okay, looks good. When we go back to our assembly and rebuild it, we'll get several mating errors because we have a missing face. If we edit one of our mates, we can easily replace this missing face with the outer cylindrical face of this part. But now, in 2015, we can choose to replace all the other missing mate references with that face as well. This allows us to fix multiple mate errors by only replacing one face and having that change propagate through the rest of our mates. It's a big time saver. The last thing we need to do is copy this arm over. So let's do it. Using copy with mates, we'll retain all of our width and angle mates to appropriately constrain the range of motion. Okay, looks good. That's what's new in assembly modeling in SolidWorks 2015. Drawings are important to many of our customers, and with this release of the software, SolidWorks continues to add functionality. The first thing I'd like to show is how we can move from the standard straight leader to the new leader style, the spline leader. This leader is especially beneficial when working on pattern drawings, or when you're just trying to place an annotation in that hard-to-reach part of a drawing view. These splines are, of course, fully editable. When adding angular dimensions, construction geometry is no longer required. You can dimension from a line to a vertex, which will bring up these axial indicators. Then you can select which indicator to dimension from and place your dimension. Once the dimension has been placed, if you want to change it, you can right-click and go to Display Options and choose from a variety of different selections. We could choose the exponential angle, or in this case, we'll go vertically opposite. The revision table has also been updated in SolidWorks 2015. Now you can add a new row by clicking the Add Revision button located in the bottom left-hand corner of the table. Now we're ready to place our revision symbol. When we place it, notice how the table automatically detects the zone it is located in. If we were to move one of our revisions, the zone would become updated in our table as well. If we want to view the zones, we can turn on View Zone Lines. These zones are new for 2015 and help locate things throughout your drawing. They are also used when using a location label. If we were to add location labels to these two views, it would help us keep track of where they're located. And notice, if we move one drawing view to a different sheet, how this location label will update. Users who have been asking for more control about how numbers are rounded will be happy with the options in 2015. If we go to our unit properties, we can change how our decimals round. We can choose to round half away from 0, half towards 0, round half to even, or truncate without rounding. In this case, let's round half to even. Notice how our value updated. When working with center marks, if the whole pattern changed, it would be common to be left with a dangling center mark. Let's go ahead and edit this whole pattern, and then we'll see how we can fix that in 2015. Okay, let's go back to the drawing. Sure enough, we have a dangling center mark. In 2015, we can simply right-click and choose to reattach. We can also right-click and choose to add another center mark set for the new hole we created. These center marks will all behave as a single group. Let's go ahead and turn on radial lines. Notice how it changes for the whole group. In SolidWorks 2015, if you want to keep some of your notes safe, you can add them to a security layer. If we right-click and choose to change the layer to our already created security layer, we can go to the layer properties and see that this layer will not print. Let's go ahead and look at our print preview. Notice how our note area does not show up and our secrets are safe. Lastly, it is common to have to move a drawing view off the sheet to get all the information you want in a drawing. However, once this is done, Zoom to Fit will zoom to include everything located in the drawing file. Customers would commonly make a custom view that just included the actual sheet. Well, in 2015, SolidWorks has made this a standard view option. You can choose Zoom to Sheet from the View Palette toolbar. That's what's new in Drawings in SolidWorks 2015.
The first thing we're going to be going over here is the VMI support. Some of our customers who use SolidWorks design models and then they want to import them into their AEC software, architectural software. SolidWorks now supports export to AEC. So first of all, I'm going to select my mounting location here and a reference point. And then I get to choose how much detail I want to show up in that AEC file. So here I'm going to choose custom, and then I get to choose which ones I want to hide. So in this case, I want to hide my fasteners. It's not necessary information for architectural software. And also, I could choose to select other components, say they're intellectual property that you don't want to get out there. You can go ahead and select individual components. This takes a second to hide everything here. What it's going to do, it's going to hide all those things that are 6% of the assembly size or smaller, which is most of the fasteners. Alrighty. I have some more further options here. I can choose to keep some features, etc. I'm just going to go ahead and get into the next window here. What this is going to do is going to remove the internal details, so you only see external faces. And also give us a preview. I should have a preview here in this right window. I'm not sure what's going on there. Anyways, what it did was it hid all the fasteners here, and it removed some of the holes. So the hole here in the AEC software was not shown. Then when I go ahead and then click on the Save as SAT file, type in my name here, and then hit Save. And then this is ready to export into the architectural software. Apologies about that preview. I didn't do anything different. So pretty simple operation there. That's useful, you know, if someone's they're designing a building and they have an elevator and say they need some buttons for the elevator, and that's something that was designed in SolidWorks. You just import it into that AEC software. SolidWorks has made 2 significant changes to routing. It now supports HVAC conduit routing. So go ahead and start a route here. You see under route properties, I have HVAC ducting, and I have a 90-degree bend elbow selected here. So just like the routing for wires or piping, just going to create a 3D sketch here. Of course, I messed up there. Trying to make them orthogonal so that it'll create the 90-degree elbow there. All right, very easy to fix it if you do make a mistake. I'm just going to go ahead and attach it there. Preview is a little iffy sometimes, but once I hit accept the sketch, you'll see that it did work properly. Now, I have some other indies up here that I want to attach to, so maybe I wanted a T here instead. Just simply delete what I had there and extend, insert a T section here. So I'm going to go into my design library, routing, HVAC, and I'm just going to apply the HVAC T. Select my configuration here and hit accept. And voila. You can slide it back and forth here. This line here is not accurate. Create a new line here at the C point. Here, let me redo that one. I'm not sure what happened there. There we go. Okay, now I'm just going to get into my line tool again. Get into my line tool here. The L key, if you're wondering how I'm getting into that. And I'm just going to make my routing to the 3 components I have up here. Now what we need to do here is we need a T, or a cross, actually, to split it into 3 different directions. Create some little stubs here on the end that can then be attached to my endpoints here. Now, the endpoints here are smaller than my current HVAC, so I need to add a reducer here. Now, the reducer will automatically size itself based on what I'm attaching it to. So you can see here it's a fairly small reducer. The middle path is much larger. Go ahead and pin this here. So when I put the HVAC on the middle path, it gives a different configuration based on the size I'm attaching it to. I can go ahead and move these around afterwards and just attach them to the C points to complete my route. Not sure what happened there. I made some lines here that probably weren't completely orthogonal. Shaky hands. So once I get into the drawing here, you can see that it created the bill of material based on my components here. And when I select components here, it highlights them in the tree here. So I have a length, a quantity. There's 2 quantities for that one, so there's another one here on the right side. It also shows my bends. So here I got a horizontal bend, 90 degree, elbow, the type, the component type. I can also create balloons for those as well, just like a standard assembly. Now there's a second type of routing that SolidWorks now supports. In 2015 is called the cable tray. Cable trays are kind of tricky because they have an open component. So you see here that it's an open U shape. So again, I'm going to start the route just by right-clicking and clicking on Start Route. Cable tray, and I have a 90-degree elbow there as well. Just going to extend this out a little bit to give room for the bend, and just going to sketch, make sure that these are orthogonal this time. So I'm going to snap them to orthogonal. And there you go. There's the cable route. I can add relationships. So here I might choose an on-face relationship to that face. And an on-face between that point and the top of this face here. Or I guess it's an on-surface relationship. And then once again, I can create a relationship for this bottom here to align it with the beginning of my cable tray route. All right, I can also insert components to my cable tray routing, just like I did in the HVAC routing. So in this case, I want to create the cable tray cross. There's only one configuration available for this component. Just drag my line out here. This is all dynamic, so it updates dynamically here. Get back into my line tool. And I'm just going to create a little bit of a route here for this. And once again, we can create relationships here in this cable tray route to dynamically link things together. Those are pretty close together. In fact, they're on top of each other, so I'm going to go ahead and slide them over a little bit. No problem. Easy to do. And now we have a cable tray route. And these cable tray routes can be used in electrical 3D to route your wires. SolidWorks has also made enhancements to weldments. So when I edit a structural member here, you have this feature manager tree, and there's groups for weldments. When I select different groups now, it gives a highlight of what that group is. Easily determine where the components are for individual groups. Also, there's a tooltip that when I hover over a group, it tells me, in this case, group 2, group 4, etc. Also, the corner treatment has been enhanced. Same functionality, but now the pop-up menu is easier to read. In the past, we had a drop-down here to choose between different groups, but now it's all in one window here. It's easier to select and visualize with the preview here what's going on here. So in this case, I can change the trim order to maybe 3. You can see how it's going to modify my weldment there. Green check mark in the box. And very easily, I can create this dynamic cut here. Well, a very challenging cut to make by hand. All right. Something else that's supported by weldments is gussets. In the past, you wouldn't be able to make a gusset between two components that have a space in between them. But now that little space, that gap there, it is not a problem. Go ahead and create my fillet, or my length for my width. And once again, I'm going to pin this so I can reuse it. There's a gusset with a gap. You can also create a gusset with a flat sheet metal. It's not sheet metal, but in this case, just a flat bracket here and a tube. And even though there's a gap there with a round corner, like a fillet there, it'll still make the gusset just fine. You can make a gusset between two round members. And in this case, orientation is subjective because I don't have a flat face that has a normal orientation. In this case, it's a round, so normal is subjective. So I can go ahead and change that as I like. That looks good to me here. Another option here is between a rectangular member and a round member. I don't see a preview yet because I need to assign a direction. So if I assign the horizontal direction, see the preview here. That's not what I want, so I'll change that to a vertical, and now that is exactly what I want. Go ahead and unpin and accept. All right, looks great. End caps have been enhanced in SolidWorks 2015. So previously, I was able to make an end cap internal or external to a face. But now I can actually make an end cap inside the tube. You can choose an offset here of 10 millimeters. I can modify the thickness of the end cap here. We want it to be 25. Change that back to 5 there. I can also choose the offset for the edges of my end cap here. In this case, maybe 2 millimeters. Wow, that's way too much. Let's change it back to 1. There we go. That looks good. I can also add a fillet to the corners. Go ahead and accept that. Now, I've prepared a section view here. You can see that when I go normal to that section view, the cut on this end cap is normal to the faces of the end cap. So I could just use like a laser cut and cut this out of sheet metal. I don't have to machine this part here. SolidWorks has made enhancements to weld beads. So I can choose multi-bodies now. This takes a second to load. So there we go. There's one body, but I can also, like I said, do multi-bodies here. So I'll select both of these round members here. And you can see it'll make a weld bead along the 2 edges. And not along the bottom, because I selected the face of this gusset. All right, looks good. I'm going to create a new weld path here. This also supports faces that might have more than one intersection. In this case here, it has 3 intersections. Also make complex weld paths for corners and sheet metal parts by selecting a face and an edge. Looks good there. Now in the case of a butt weld, I'm going to go ahead and change this from weld geometry to weld path and just select an edge here. I can select any edge I want to create a weld path. So in that case, the butt weld, I can also choose the edges of this gusset here. And it doesn't matter that there is a gap here. It'll still create the weld path for me. Now you can also use something more complex, like a sketch, for example, if you have a really complicated weld, and it will create a weld bead along that sketch. Cut list has been upgraded. It now has this option to update automatically, which is very nice. Also, the properties have been updated. So for this particular cut list, this cut item here, I have quantity and total length. These were created automatically. The quantity is 2 here, and it highlights 2 different items. That can be used in the bill of material. It can also be used as annotations. Really nice enhancement there. Another good enhancement to the cut list is the ability to change the name here. Cut list item 32, parentheses 2 doesn't mean anything to me at all. So what I can do is go into weldments and assign the description property to the cut list. So see now when I accept that, it's the TR 3 by 2 by 0.25. So it gives me the dimensions of the weldment feature and the abbreviation. Very handy enhancement. Now some things that we might want to group together in the tree are easier to do that in 2015 than ever before. We have some weld prep here. We have a fillet. We have a chamfer here for this weld. These chamfers are here in the tree. Sometimes it's easy to group these together in the tree, but other times they might be in various different locations throughout the tree, and you can't simply group them into one folder because of the parent-child relationship. Well, now I can add those to the favorites folder here, and in the favorites folder I can go ahead and create a subfolder. And in this case I can name it weld prep. Then in different configurations for my model, I can easily suppress all the weld prep features if necessary. Chain component is a new pattern type in SolidWorks 2015. As you can see, when I move these sprockets here, the red link moves dynamically. This chain was created using a chain pattern. The way to do that, we already have a setup here for that. So the way to do that is to have a path. We're in an assembly here, and the path we created was inside of a part, but it's just currently floating. I'm going to fix it for now. I will float it later. I have an end component and a beginning component of my chain, and a link, of course. So I'm going to go to linear pattern here, hit the drop down, and choose chain component pattern. There's 3 different types of chain component patterns. There is the distance linkage, and then there is the connected linkage. Now I will show you the differences. I'll demonstrate the differences between those 3. I'm going to use the selection manager here to select my path. That's not correct. I meant to hit the little tangent propagation button there. I'm going to go ahead and accept that path. I can fill the path here, or I can select a number of entities to be patterned. Here I'm going to select my part. Now it's asking for a reference here. Some of you probably know that SolidWorks is very good at telling you what it wants. It's asking for a path link here, a linear edge or reference axis. So I'm going to select the edge here on the circle, and it wants an alignment plane so that this link doesn't just rotate in and out of the pattern here. So I'm going to show planes here and select the front plane here, and then go ahead and turn planes off. It's a nice preview there. If I accept that, and I can move this along the path. You can see that it rotates around that one reference that I created, that circular edge reference. That's not exactly what I wanted, so I'm going to change this to a distance linkage, and I'm going to select the other reference here. Actually, I have to click in the window, excuse me. Select the other reference there, and accept that. Now, this is called the distance linkage. You can see that this component no longer is able to rotate around the path. It will follow the path, and the path will go through the centers of those 2 arcs. Now, perhaps the most powerful and desirable option is connected linkage. It will link those components together based on the 2 references, the circular edges in this case. It could be a face or an axis. Note that there's an option here for chain group 2. So for in the circumstance that you create a bicycle, there's 2 different linkages types. There's the small linkage and then the big linkage. So that's what this is for. In this case, I only want one type of linkage. Go ahead and accept that. Actually, let me change the number of instances to 19 here. You can see this now slides back and forth very nicely. It's actually an IGUS chain for cables. Create a couple mates here. It looks broken, but once I rebuild, you'll see that it's not broken. I'm also going to create a mate for the beginning linkage. In this case, I'm actually going to use something that you just learned about, the profile center. I'll lock the rotation, hit accept. Once again, it looks like it's broken, but if I rebuild, see that it is not broken. It's not rebuilding. I'll go ahead and float this sketch here, and then I can drag this back and forth. Not sure why that didn't rebuild. Sometimes if you suppress the linkage and then unsuppress it, it'll rebuild it. Not in this case. To demonstrate when you might want to create those types of patterns, I have an assembly here prepared. If I drag my assembly, you'll see that the IGUS chain down here updates automatically. The other type of chain here is different in that the sketch is going to transform. So when I move this actuator, this linear actuator, it does not automatically rebuild because the sketch needs to be rebuilt. So go ahead and do a rebuild, and you see that it will rebuild the IGUS chain, but the sketch geometry changes. there have been enhancements to sheet metal. So in 2014, we created we allowed the lofted bin to create actual bin geometry instead of approximations. There was a requirement that the sketch planes had to be parallel. Prepare this configuration with just the sketch profiles. So you can see that the two profiles are not parallel to each other at all. If I go into lofted bin, you see here the formed option, which was available to you previous to 2014, says that the methods are only approximate. So we want to use the bent option here, because this is going to give us an accurate flat pattern. Just going to select my two profiles here, and you can see that even though they're not parallel to each other, it still creates this lofted chute, the sheet metal chute. Of course, I can change my fastening options here. I can chord tolerance, segment length, etc. And when I flatten this, you'll see that it gives accurate flat pattern with bend angles, or bend lines, excuse me. All right, let's go back to the completed model here, because we need to make some changes to it. You might notice that this sheet metal gusset here, the sheet metal chute, has some gussets in it. These gussets are created after the flange was created using a break operation. But sometimes designers want to see the profile of the gussets in the flat pattern because they want to make sure that it doesn't overlap any existing features here. So you see this is possible if you go to Document Properties, Sheet Metal, and you select Show Sheet Metal Gusset Profiles when flattened, Show Sheet Metal Gusset Centers when flattened. So, Document Properties, Sheet Metal. Now we can easily see that these gussets do not overlap any of the holes or any of the edges of the flanges. Now when creating a sketched bin, we can now see a preview of what the sketched bin will look like. Makes it easier than ever to create our sketched bins. You can select a fixed face here. You can see that it shows a little bit of a preview here. Okay, I can easily determine that that's not how I want this to look. So I'm going to change the angle here, and it will update the preview. But it's still not quite in the right position here, so let me flip that angle there. And it will show the preview. But I have the wrong bend position type here. It actually cannot create this bend here with this bend position. So I need to change it to the bend outside. It has to do with the sketch being on the edge. So there we go. There's a nice preview there. I'm going to go ahead and accept that. And that is all the updates for sheet metal in 2015. There is now a new option here that when you mirror the part, it will maintain the sheet metal information in the flat pattern. In the past, when you mirrored your sheet metal part, you might see a flat pattern where the bends are off the sheet somewhere. That is no longer the case in 2015. There have been some changes to surfacing as well. In the past, we added this spline, the style spline. We still had the original spline, but now in 2015 we can turn a regular spline into a style spline by right-clicking on it and choosing Convert to Style Spline. Now we can choose the number of curve degree that we want here. So third degree, second degree, etc. Here I'm going to choose fifth degree. I can go ahead and move these around if I want, or go ahead and put them back in the approximate location it was before. It's a really nice tool there to be able to convert to style spline. In the past, we've always been able to split solid bodies, but now, using the split command and the sketch I have created here, I can split the surface body here. Now I have 4 different surface bodies. Go ahead and find the one I want and isolate it here. Spline on surface has also been improved. Spline on surface used to only work for one face of a surface, but now I can go across multiple faces. See, there's a face. All these different previews here are showing individual faces for this surface body. I'm going to go ahead and create my spline across multiple faces here. All right, looks pretty good. I'm going to create a relationship here. See what direction? It looks like the Z direction. So now those 2 points are aligned in the Z direction. Go ahead and move them around dynamically. All right, looks good. I can also use this to split the surface, just like I could in the past. So trim surface with this sketch entity here. I'm going to keep the selection of the inside or the outside here and accept that. A very powerful tool that's new 2015 is the flatten surface. Simply select the surfaces, the faces on the surface, excuse me. I think I missed this one here. There we go. And select a point to stay stationary. Okay, that didn't work because this face was missing. So go ahead and select that face again, and then select the vertex of that face. I can also choose control curves to control the shape of my flattened surface. I hope the face and surface dialog is not confusing you. A surface body can have multiple faces, just like a solid body can have multiple faces. A face is not the whole surface. It actually looks like about 7 faces here. I'm going to go ahead and accept that, and now I can do some diagnostics on this. I can create a deformation plot here to show the stretch and shrink of the face. So you can see here that it has stretched about 18% to maximum and 18% at the minimum. This can help you detect problems in manufacturing. Go ahead and turn that off. Another very powerful tool is to export to DXF. Save that on the desktop there. I'm going to choose a reference point and hit accept. It shows me a little window here of what the DXF is going to look like. It's going to be printed out and used to cut fabric. Very powerful tool. All right, that is surfacing for 2015. We've also created some additional power for the design interface of solid parts here. So see, I have a fillet here. In the past, we've created functionality for conic fillets, but now we have this ability to create an asymmetric fillet. So the radius on one face here is going to be 5 millimeters. The radius on the other face is going to be 10 millimeters. Let me reverse that here. Very easily change the shape of my fillet. Once it loads. There we go. There are now additional tools when creating a surface fill command. Surface fill is the name of the feature here. I can now show curvature combs and zebra stripes while I'm doing the surface fill. Instead of create the surface fill, then look at the curvature combs or zebra stripes. Now I can do this while I'm creating the feature. That's crazy there, so I'm going to change the scale here to 1. Alright, that looks better. I can also increase the density of the curvature combs. So you can easily see how the curvature of this face, not a very sharp angle here, but it gets curvature increases and then the curvature decreases. I can also show the zebra stripes here, which also demonstrate visually the curvature of the face. Alright, I have 2 bodies here, so I'm going to go ahead and hide that top body there. I've prepared a sketch here to cut with. Now you might notice that this cut has an open profile on it. Before you'd have to do like a send feature, but now there's an option to use selected contours. Contours is available for extrudes in the past and for cut extrudes in the past, but now I can use it with the edges of my faces here. So there's an edge, there's a circular edge there. I can select that as a contour and create my cut. Creating planes in SolidWorks is now easier than ever. When you create a reference plane and select a point or a vertex between 2 faces, you now have this option to create a plane parallel to the screen, the actual orientation of the screen. I can now use that plane to create a section view. I can rotate this around and everything like that, and it maintains that section view. But if I did want to update that plane to this new surface, this new screen view here, I can edit the plane. In this case, it was plane 24, and update plane. The plane now updates to my current view, and I'm just going to turn off and turn on the section view here, and you see that updates the section view. Very powerful tools to help you design solid bodies. There's now a new way to render. I need to add in my photo view 360 here. Rendering is very resource intensive. Even on a small part like this, it could take a little while. On big assemblies, in the past you'd render it, okay, that's not exactly what I want, change the settings, and then render it again. Now, there's this preview window here. Simply select a preview window here. It's loading. And it will only render a small section. It has never done this in the past. So there's a preview window there. I can also use an integrated preview. Something new always happens when you're doing a live demo. There we go. There's a dynamic render there. I can rotate this around here. You can see that it now renders. So see something I might notice here. This face is yellow. Oh, I didn't want that face to be yellow. I can go ahead and change that to red without using all that time to render the full model. And that's all I have.